Hello and welcome to episode 14 of Going Places. I am Beth Bartel and I am here again with my friend Wendy. Hi, Wendy.
Yay! I'm so happy to be here. I love working with Beth. Yay!
Even if we have to be remote, halfway across the country, but here we are together. I don't know if this will show up. Could we like high
five?
Just doesn't.
Today, we're going to be talking about one of my very favorite places on earth. And I know I say that every time, but I really do mean it every time. So I'm going to share my screen now and take you on a geologic adventure to California, which may not sound that exotic, but you know what? California is amazing. It's part of the plate boundary between the North American and Pacific plates. And as such, it has really interesting and incredible geography and geology. So do you see how there's a bunch of mountains over here in the upper right-hand corner, and then it's really kind of more flat in the lower left-hand corner? There's almost like a line you can see that separates those two areas. That line is the very famous San Andreas Fault. So we're going to fly into the most famous part of the fault, probably, which is called Wallace Creek. There's actually an interpretive trail that you can go to and learn more about the fault if you come to this area. So if you ever get a chance to do that, it's amazing. But I want to point out, do you see this river or stream that's coming down and all of a sudden it takes this jog over to the side and then continues? That's because that little stream has been moved by motion along the San Andreas Fault. So the San Andreas is a strike-slip fault, which means that one piece of rock is sliding past another piece. And it's a right lateral strike-slip fault, which means that if you're standing over here on the road looking across, looks like everything has moved over to the right. So let's look at some other fault features in this area. You can see there's lots of these streams that are either non-existent on the other side of the fault, they've been beheaded, or they've slipped over and moved. We can go along the fault and look at all these different examples where you see things like that. Look at this beautiful, very clear stream offset. So the last time there was an earthquake on this part of the fault was in 1857. This is in the Carrizo Plain, near Taft. We'll keep going down. Look at all of these amazing fault features. Sometimes you actually even kind of lose the fault, right? So in this particular area, we found some really interesting things. So working with Ramon Aerosmith and others at ASU and some other places in California, other universities with other researchers, we have dug a series of paleoseismic trenches across this part of the fault and other parts of the fault with the purpose of understanding what's happened to the fault in the past. How often did it have earthquakes? How big were those earthquakes? And the reason we want to know that is so that we can help to determine what might happen in the future. So if we learn that this fault has earthquakes every X number of years, then we can say it's likely to have earthquakes along that same cycle, and we can understand the seismic hazard that it poses a little bit better. So can we see this picture? Can you see that, Beth?
Yeah.
Okay, this is what that area I was just showing you looks like on the ground. It's not as obvious as it is from the air, right? It's always a lot harder to figure out what's going on with the geology on the ground. But this line right here is showing the San Andreas Fault. Now, if we fly up, I can show you, these are the trenches that I was talking about, paleoseismic trenches that you dig across the fault to look down inside the fault itself. And then this is what those trenches look like. And so you make sure that they're supported, and then you take pictures of the walls, and you can date different parts of the sediment that's in there. So you're doing carbon-14 or other things in order to figure out the ages and the times when earthquakes happened in the past. So the San Andreas Fault is a really, really amazing and wonderful feature. It's very cool that this part of California over here on the lower left is actually moving up towards San Francisco at about the rate that your fingernails grow.
That is so cool. Could you zoom back into Wallace Creek for a minute?
Absolutely.
I have a few things to point out that I think are kind of neat. So I love vocabulary, partly because I love words, and also because we use words to actually explain concepts. And you talked about right lateral, which is a term that a lot of people won't need ever, but in case you're curious, right lateral, how do you tell the motion along the fault and whether we're going to call it right lateral or left lateral? And you pointed out that if we are on that southwest side of the fault,
Mhm.
Yep, and we look northeast, we can see that the area to the northeast moved to the right. Well, how do we know which side of the fault we want to be on to make that distinction?
Let me see if I can spin the world. I don't think I can.
Ah,
It doesn't matter which side you stand on. Let's imagine now that we're standing right over here and looking across at the road. You can imagine flipping yourself over. It would still look like everything moved to the right because right
it's
lateral is the same no matter which side of the fault you're standing on. There's also left lateral strike slip faults that have a different sense of motion, the opposite direction, so everything would look like it moved to the left.
It's like magic. So I like to think of standing on one side of a fault and facing the fault and facing my friends and family on the other side. What direction would they be moving? What hand would I use to wave exactly to say, bye, wait, come back? And then there was another word that you used a lot that was really cool. Could you break down the word paleoseismic for us?
Yes. So seismology is the study of earthquakes. Paleo, I guess, means older. So paleoseismology is the study of older earthquakes. And we do that because we think that the past is really the key to the present. And we can learn a lot about what might happen in the future if we can determine what's happened in the past.
That's great. So we can use these studies that you were working on to better understand our earthquake hazard in California.
Yes, lots and lots of amazingly smart people are working on these things. Follow me on Twitter at Dr. Wendy Rocks, and I can direct you to all of these amazing paleoseismologists and geomorphologists and geologists and seismologists who are working together to make sure that we can understand seismic hazard and that we can prepare to survive any earthquakes and thrive in their aftermath.
Fantastic. Thank you so much, Dr. Bohon.
Thanks
And
for having me. Good to see you, everybody.
yay, looking forward to next time.
Yay!
Bye.